Welcome to the video presentation. I'm Jiarong, the PD student in Monash University. My supervisor is Hao and Ariel. Today, I will introduce my research project, Multi-Agent Reinforcement Learning for Electric Vehicle Coordination. With the increase in the number of fuel vehicles, the emissions of vehicles became an important source of air pollution, which also led to climate change. Therefore, the government encourages people to use electric vehicles to reduce emissions. However, the usage of EVs will bring some problems to both charging stations and users. In the real-world application, the charging station wants the EV charging to maximize the usage of solar energy. For EV users, they want to minimize the cost of EV charging and satisfy the charging demand. Therefore, a charging algorithm is necessary in this situation. One challenge of the problem is uncertainty, which comes from the EV arrival time, real-time price, and solar energy generation. The research problem is, can we minimize costs and maximize user satisfaction under uncertainty? To deal with the uncertainty of the problem, we model this problem as a multi-agent Markov decision process and solve the problem by multi-agent reinforcement learning. This graph shows the high-level structure of the system. The charging station has installed solar panel, so the energy supply came from grid and solar energy. Each charging point supports both charging and discharge. The discharge action can reduce the cost during high price time. We also consider the battery degradation cost during discharge. MTP requires us to define three parts: state, reward, and action. The state includes charging information. Action is charging rate. The reward is the cost of energy purchasing from grid and the penalty for incompleted charge. In the problem, we use multi-agent deep Q network to minimize the quality of decision. After the training process, the Q network has good performance for action evaluation. According to the experimental result, we can see the algorithm can keep certification rate at 94%. We assume that the user is satisfied when more than 80% of charging task is completed. The monthly cost will reduce up to 20%. As the cost decrease, we can see the solar energy usage is increased. The algorithm can reduce cost by charging cost control and maximizing the solar energy usage. In conclusion, this research proposed a multi-agent reinforcement learning to solve the problem of EV charging scheduling under uncertainty. The experimental result showed the algorithm is effective. Our algorithm is centralized and has a high communication cost, which will cost the delay of the decision. Therefore, a decentralized algorithm is necessary in the future.